Welcome everyone to Network Analysis with Arkime. My name is Josh Stroschein and I'll be your instructor for this course. I'm really excited that you're here, so let's get started with some of the background information about Arkime. Arkime was originally created by Andy Wick and is formally known as Moloch. Arkime augments your current security infrastructure to allow you to store and index network traffic in standard PCAP format. The power of this is that it provides fast, indexed access. It has an intuitive and simple web interface provided for PCAP browsing, searching, and even exporting. This project is a large-scale, open source, and provides index packet capture and search. It is currently available under the Apache 2.0 open source license, and you can download it at arkime.com. There are three components that comprise the Arkime project, and you'll learn about those in this course. The first is the capture component. This is a threaded C application that is used to capture the network traffic. This can either capture traffic live on the network, or it can process PCAPs, which is what we'll do in this course. There is a viewer, which is an intuitive Node.js application, and where we'll spend most of our time performing traffic analysis. And finally, there's Elastic, which can be installed as part of the default Arkime setup. Before we get into all the technical details of Arkime, let's spend a few moments discussing some of the different cybersecurity frameworks. First up is the NIST Cybersecurity Framework. This framework provides for the ability to manage cybersecurity risks across the enterprise with both internal and external stakeholders. At its core, it provides a set of functions to achieve specific cybersecurity outcomes, which you can see here: identify, protect, detect, respond, and recover. Each function can be further broken down into categories and are closely tied to the programmatic needs and particular activities to defend an organization. Arkime helps an organization fill the gaps in the anomalies and events and security continuous monitoring categories. We can break this down even further because the CSF provides subcategories tied to specific technical activities. Arkime then can help to ensure that detected events are analyzed to understand attack targets and methods. The impact of events is determined during analysis, and that the network is monitored to detect potential cybersecurity events. The demonstrations that we'll have later in this course will help tie these concepts together. Next up, let's take a look at MITRE ATT&CK. MITRE ATT&CK provides different attack techniques that adversaries can use against an organization. For this course, we're going to look specifically at network analysis. And while Arkime can provide the ability to view all of the traffic that goes across your network, we're specifically going to focus on prevalent attack techniques. The first one is phishing, and more precisely, spear phishing attachments. We're also going to take a look at application layer protocols. It is very common for attackers to utilize common web protocols such as HTTP when they're communicating with command and control nodes. And finally, we'll take a look at exfiltration over C2 channels. MITRE Shield is another framework that helps you to map the different attack techniques to steps you can take in order to defend your network. So if we map the attack techniques and sub-techniques to MITRE Shield, we'll be able to look at different categories, such as DTE 0021, hunting, the process of searching for the presence of or information about an adversary. DTE 0027, network monitoring, in that the defender can implement network monitoring for and alert on anomalous traffic patterns, large or unexpected data transfers, and other activity that may reveal the presence of an adversary. While we're not going to use Arkime to generate alerts, Arkime does allow us then to investigate and perform network traffic analysis to identify these patterns. Arkime also has the ability to integrate with popular and open source intrusion detection systems, so you can potentially get alert information into your Arkime setup. And finally, we have DTE 0028, PCAP collection. That's one of the main capabilities that Arkime provides, is the ability to collect full packet capture of all network traffic. This allows you to review historically what's happened over your network to help reconstruct events, identify patterns that maybe were previously undiscovered, and overall have a greater capability to defend your network. So where does Arkime fit in to a standard enterprise setup? Well, the deployment really depends on where you want to have coverage. At its core, Arkime needs to be able to monitor network traffic. So any segment on your network that you want to provide that full packet capture ability is where you want to consider placing an Arkime sensor. Once an Arkime sensor is deployed, it begins performing not only the full packet capture, but also submitting data to an Elastic cluster. What Arkime submits to Elastic is just metadata about the traffic, and this is the content that you'll see in the viewer. This is what gives you the ability to search through your network traffic data. When you need to look at the data that was not part of this indexed metadata, it also has the ability through the viewer to load that data for you or allow you to export the PCAP for more detailed analysis. As we wrap up this introduction, there is a common attack scenario that I want you to keep in mind as we're going through the different demonstrations and performing our network traffic analysis. This is a very common pattern that we see right now. That is that a threat actor, group, or an adversary decides to attach an Office document to an email and try to get that in front of a potential victim. Those Office documents then oftentimes contain macros, and those macros, while a normal part of the Office suite, those are used to achieve code execution. If the user can be social engineered into enabling that content, then there's typically additional stages that occur. PowerShell may be executed or used to download the next stage payload. There's really any number of different techniques that can be utilized at this stage. Eventually, though, the malware is dropped in the environment, and we move into a post-infection phase. During this time, there is often key network activity that occurs. It is very common to see HTTP used to request the executable, and those executables are oftentimes stored at compromised hosts, legitimate websites that have been compromised in order to host the malware. Once the malware has been introduced into the environment, then we'll see a shift in the command and control, the infrastructure that it's using in order to check in, to receive further instructions, and to exfiltrate data. It's at these later stages of initial attack that we're going to be looking at and analyzing the network traffic. I hope you're ready to get hands-on with Arkime. Let's get started.